Let's work through an example to see how one would calculate EV and CV. So we're going to look at a consumer who has perfect substitutes utility. His utility from consuming Q1 units of good 1 and Q2 units of good 2 is 2Q1 plus 2Q2. So let's start with in a world where the price of good 1 is 1 and the price of good 2 is 2 and the consumer's income is 200. What we're going to do is to calculate the change in welfare from an increase of the price from 1 to 4. So good 1 is going to, it costs 1 at first, and we're going to increase the price to 4 and see how that affects the consumer's welfare. So the first step is to find the old and the new utilities. So to find the old utility, we first have to calculate what the initial demand is. Remember, this person has perfect substitutes utility. Their utility is U of Q1 plus Q2 equals 2Q1 plus 2Q2. So their marginal rate of substitution, or the slope of their indifference curves, remember, are straight lines, and the slope of these straight lines is always going to be -1 because their marginal utilities are 2 from each of the two goods. So you're just always going to buy the cheaper of the two goods, and you don't buy any of the more expensive of the two goods. And if they have the same price, then you just spend all your income on the two goods in any proportion. So if you go back to chapter 3, that's what we found to be the perfect substitutes demand. Before the price change, remember the price of good 1 was 1 and the price of good 2 was 2. Since price of good 1 is less than the price of good 2, he's going to consume only good 1 and none of good 2. So the quantity of good 2 that the consumer consumes is 0. They're going to spend all of their income, which is $200. They're going to spend all of that on good 1. Since the price of good 1 is 1, they buy 200 units of good 1. So their initial utility, right, that's the old utility, is 2 times Q1, so it's 2Q1 plus 2Q2. Q2 is 0. Q1 is 200, so it's 2 times 200 plus 2 times 0, which is 400. Now we calculate the demand after the change. The price of good 1 rises from 1 to 4. Once it rises to 4, good 1 is more expensive than good 2. Remember, P2 is 2. 4 is bigger than 2, so you buy only good 2. So the consumer is going to spend all his money on good 2 and is going to buy none of good 1. So the demand is going to be 0 units of good 1, spend all of your money on good 2. The price of good 2 is 2. You've got $200, so it's $200 at a price of 2. You can buy 100 units. So the final utility, so the new utility, is going to be 2 times Q1, which is 0, plus 2 times Q2, which is 100. So it's 2 times 100, which is 200. So when the price went up from good 1, the price was 1, it increased to P1 prime, which is 4. That caused a decrease in the utility. So what we want to do now is calculate the equivalent and compensating variations from this price change. So let's start with the equivalent variation. Remember, the equivalent variation is the change in income that is equivalent to the change in price. So if I were to take away EV dollars, it would be equivalent to increasing the price. So let's suppose that you had, instead of the Y dollars you started with, you had Y dollars with X dollars taken out of it. But the old prices remain. Then how much of good 1 are you going to buy? Remember, good 1 is cheaper at the old prices than good 2. So you're going to buy 0 units of good 2. You're going to spend all of the Y dollars with the X dollars taken out of it on good 1. So that's 200 minus X divided by 1. So you're going to buy 200 minus X units of good 1. You're going to buy 0 units of good 2. So your utility at the old prices if I take away X dollars, is going to be 2 times the amount of good 1 that you buy plus 2 times the amount of good 2 that you buy, which is going to be 2 times 200 minus X plus 2 times 0. Now what we want to do is we want to find X such that you'd be indifferent between having X dollars taken out of your income at the old prices or having the new prices and not having any money taken out, which we figured out gives you utility of 200. So what we're going to do is we're going to equate your utility when X dollars are taken away from you at the old prices and the utility you get from the new prices and no money taken out of your budget. So we equate this with this, and if we solve for X, that's going to be 400 minus 2X equals 200. Solving for X, we get 200 equals 2X, X equals 100. So X equals 100 gives us the magnitude of the equivalent variation. Now, always when you calculate this is going to tell us how much money could be taken away from you. Now, to calculate the sign, remember the negative sign represents that you're worse off, a positive sign represents that you're better off. So since the price increase makes you worse off, the equivalent variation is going to be represented by minus 100. Okay, now let's calculate the compensating variation. The compensating variation is the amount of money that I would have to give you so that at the new prices you would have the same utility as you had before the price went up. So it's how much I would have to compensate you for the price change. So let's suppose I give you X dollars and the prices are the new prices. So your total income is going to be the Y dollars you started with plus X dollars. Well, what's your demand going to be? Remember, we're looking at the new prices. The new prices, P1 prime equals 4, P2 equals 2. So since it doesn't matter what your income is, because this guy has perfect substitutes utility, whenever P1 is, the price of good 1 is higher than the price of good 2, you don't buy any of good 1, you buy only good 2. So you're going to spend this entire Y plus X dollars on good 2. So you spend Y plus X dollars on good 2. The price is 2, so you can afford, remember Y is 200, so you can afford to buy 200 plus X divided by 2, or in other words, 100 plus X over 2 units of good 2, and you don't buy any of good 1. So your utility, when the prices are the new prices, your utility, if I compensate you with X dollars, is going to be 2 times the quantity of good 1, which is 0, plus 2 times the quantity of good 2, which is 100 plus X over 2. So that's going to be 200 plus X. Now what we want is to figure out how much money do I need to give you for your utility after I compensate you with X dollars at the new prices to be equal to your original utility. So remember, your original utility, when you had Y dollars, which is 200, and the old prices, your utility was 400. So we're going to equate these things and solve for X. So we're going to look for X such that 200 plus X equals 400. So X is going to be equal to 200. So this consumer would have to receive $200 for us to be able to compensate them for the price increase. So if I give you $200 and increase the price, that's equivalent to not doing anything. Now remember, again, this is the magnitude of the compensating variation. It's always best to calculate the magnitude, don't worry about the sign, And then once you've calculated the magnitude, then think, okay, is this a negative or a positive number? Remember, this change we know makes the consumer worse off. The price went up. The consumer's not going to be better off. So the consumer is going to be worse off. So the compensating variation is going to have a negative value. So the compensating variation is going to be minus 200. There's actually another way to calculate the compensating and equivalent variations. We can use the expenditure function directly. So remember, the equivalent variation is the expenditure to get to the new utility at the old prices minus the expenditure to get to the new utility at the new prices. Compensating variation is expenditure to get to the old utility at the old prices minus the expenditure to get to the old utility at the new prices. So let's go through how you would use the expenditure function to calculate the equivalent and compensating variations for the same example. So the same example, the utility function is 2q1 plus 2q2. So the cheapest expenditure is the cheapest way to get to u bar at the prices p1, p2. So we've looked at this in the previous chapter. So whenever the price of good 1 is less than the price of good 2, you're going to buy only good 1. So how much of good 1 would you need in order to get utility level u bar? Well, if I gave you u bar over 2 units, and I didn't give you any q2, then your utility is going to be 2 times u bar over 2, which is just u bar. What is that going to cost? Well, if I give you u bar over 2 units, then the cost of that is just the price of good 1 times u bar over 2. So whenever p1 is less than p2, you're going to buy only q1. And how many units do you need to buy? You need to buy u bar over 2. That costs p1 times u bar over 2. So the cost of getting utility u bar is just p1 u bar over 2. On the other hand, if p1 is bigger than p2, you buy only good 2. And by similar reasoning, you only need u bar over 2 units of good 2. And the cost of that is going to be p2 u bar over 2. If they're equal, then you can buy any combination of goods 1 and 2. Whatever you buy, you need to buy total of u bar over 2 units of it. And the cost of that is going to be p1 times u bar over 2, which is equal to p2 over u bar over 2 when p1 and p2 are equal. So your expenditure function is the following. The cheapest way to get to u bar when the prices of the goods are p1 and p2 is if p1 is less than p2, p1 u bar over 2. If p2 is less than p1, then p2 u bar over 2. And if they're all equal to some p, then p times u bar over 2. You know what? In other words, you take the smaller of p1 and p2 times u bar over 2. Okay, now we've got this expenditure function. So now we can calculate very easily, if we remember this formula, we can calculate very easily the equivalent variation. We just plug in p1, p2, p1 prime, and the new utility to get equivalent variation is expenditure at the prices 1, 2 to get to utility 200 minus the expenditure at the prices 4, 2 to get to the utility 200. Plug those into our expenditure function. We're going to get 1 times 200 over 2 minus, because we're going to be in the first case. And for this one, we're going to be in the second case because P2 is smaller than P1. So we plug in 2, which is P2, times U bar over, which is, U bar is 200 over 2. So that's 100 minus 200, which is negative 100. Compensating variation is very similar. Instead of the new utility, we plug in the old utility, which remember was 400. So we get that the answer is going to be minus 200. Now these are the same exact values we found for the compensating and equivalent variation with the earlier approach. Now the consumer started with $200. So a way to interpret the equivalent variation of minus 100 is that the consumer is indifferent between two different scenarios. Prices of 1 and 2 for goods 1 and 2 respectively, and an income of 100, which is their original income plus the equivalent variation or minus the magnitude of the equivalent variation, or the prices of 4-2, which is the new prices, and the original income of 200. So the consumer is indifferent between these two things. And the interpretation of the compensating variation is that the consumer is indifferent between the original prices and the original income, or the new prices and the income plus some compensation. The main conceptual difference here is between the equivalent and compensating variation is the reference utility level that we use. Equivalent variation uses the new utility level, whereas compensating variation uses the old utility level. That's the main difference here.